Okay, hi everyone. I'm going to be talking about how to normalize Punnett squares when one of our genotypes we know is not being exhibited in the phenotypes. So let's just start with a very quick, easy problem here. We're going to look at the probability that this individual 2-2, that's this male, is heterozygous. So one thing we just need to figure out first is their mode of inheritance. Since we have two parents that are unaffected, that means that they must be carriers. Therefore, we know that this is a recessive trait. And we have a female affected here, which means that if we had a recessive trait being passed down, that for the female to be affected by both parents, which would be carriers, it has to be autosomal. Otherwise, the male would be affected. It is not X-linked. So we have a recessive autosomal condition. So what are the genotypes? We would have heterozygous parents, they're carriers. We have an affected daughter, and then we don't know this individual. So what we would usually do is draw a Punnett square. We have our two parents. We have the mother up here. We have the father over here, and our probabilities of the genotypes for our son in this pedigree. One thing that we need to consider, though, is that the son is unaffected, and that rules out the homozygous recessive genotype in the individual. So when we calculate the probability that they are heterozygous, we would look at the remaining probabilities of the heterozygosity, which is 2/3, because we've eliminated the fourth genotype. So visually, this can be very easy to understand, but today I'm going to just show kind of the math behind it. So 1/3 for homozygous dominant. So we're no longer looking in quarters because we removed one. So just to kind of look at the math of how this works, here's just another example. If we were to look at here of looking at the probability that you would grab a red marble, if we were to mix a bunch of marbles together that were 30 red and 30 white, and we threw them into this container here and then grabbed one out, let's just figure out what would the probability be that you would grab a red marble. Well, our total is 60. And we have 30 red over 60 total, which would give us 1/2. So you have a 50% chance of grabbing a red marble. Okay, so what we're gonna do is we're gonna change the total number and then renormalize our values. So it's the same scenario, but what we've done is we've removed 10 white marbles. Okay, so our total was 60. We removed 10. So now our new total is 50. Okay, it's important to keep track of this. Now if we were to put them in, what we have is we're going to go back to our original where we had 30 red marbles. Now we're going to divide by the new total, which is 50. And that's going to give us, you could reduce it to 3/5, which is the same as the probability being 0.6 or a 60% chance. So you can see that when we removed options, what happened was we increased the probability of us taking a red marble out. And what we did that by taking our original probability and dividing by our new total. Okay, so let's look at this in the context of our Punnett square. So we originally had, I'm going to write this out in writing. If we were to look at the probability that 2-2 is heterozygous, originally, before knowing what they were, it was 1/2, because it would be 1/4 plus 1/4, being heterozygous, big A, little a. What we've done now is we've changed the total, which was 1, and we removed a quarter of the options, which was the homozygous recessive. So our new total is 3/4. So if we looked at the original probability, which was 1/2, we're now dividing by the new total, which is 3/4, to figure out the probability. So if we wanted to do a little simple arithmetic here, what we can do is we can reverse the fractions and multiply them. So we have 4/3, and that gives us 4/6, which we can reduce to 2/3. So that's how we use the math to figure out the probability after normalizing when we eliminate the homozygous recessive. So I hope today's lesson explained that. I hope this made sense. If you have any questions, don't forget to comment and don't forget to subscribe. Have a good day. Bye.